So we've got number 3 here. It's a little bit fancier integrand. It's got a natural log of x plus 3x. But they did tell us 3 trapezoids, and we would always assume, if they don't say it, but they tell you how many trapezoids, how many rectangles, we assume, or it's implied, I should say, that it's equal subintervals. So we're going to do our usual, which is to go figure out how much space that would be. Now, when it's the width, we did the subtraction thing up here, like this guy right here. But now when you're talking about that width right there, it's actually the height. If you look over here, this would be the height, right? So in fact, let me go over here from 2 to 3. That seems like a base to us, but it's actually the height of the trapezoid, because you take that trapezoid right there and you turn it sideways and it looks like this now. And this is now the height, and this is your base in your base, right? So, so basic idea is to still go find that width, which actually turns out to be the height. We'll just say width of interval, also known as the height, okay, because that's going to be the height in our formula. It's going to be the high minus the low for your integration limits, and then you're going to divide by the 3. And that's 18 over 3, which is going to be a 6. So that leads us to this following table. And this table needs to be a little bit wider, even though we're only going to have, let's see, a certain number of values in here. We're going to need some space in here, and I'll show you why in just a second. So take your 2, that's where we started right here, and we're going to add 6, and we'll get 8. Add 6 more, get 14. Add 6 more, and get 20. Now, for your function values, your f of x values, or g of x, whatever you want to call it, we are just plugging into this function. So you're going to get ln of 2 plus 3 times 2, which is 6. Then you get ln of 8 plus 3 times 8, which is 24. And you'll notice I'm putting parentheses around the x value for the natural log function, because I don't want it to look like this, ln of 14 plus 42, because somebody might think we're talking about ln of 56, which we are definitely not looking for. Okay, so let's make sure we're clear on that, get some proper notation in there. What you could do is put the 3x in front of the ln x if you'd like, but either way. All right, so next up we got ln of, let's see, 20 is going in, and then we're going to add 20 times 3, which is 60. All right, so we have all the y values, okay? And now just thinking of a picture, you're thinking something like this, and you're going to pick a couple of spots, and you're going to grab these, and you're going to grab those, and you're going to grab those. So we need these areas, right? So think of it this way. You've got a 2, you got an 8, you got a 14, and a 20. And again, I don't even know that this is what f of x looks like. In fact, I'm pretty sure it doesn't look like that. But a basic idea of a picture in your head or on paper sometimes helps tremendously. So as a reminder, this right here, that's that 6 we were talking about. This is also a 6, and so on. So that's your height. All right, so keep in mind what we did on the last problem where we did this little doubling thing. So the integral from 2 to 20, ln of x plus 3x dx can be approximated by, we're going to go put the 1/2 out front. We're also going to put that common height of 6 out front. And then inside, we're going to take these guys right here. We're going to take, in fact, I'm going to be slick about it. I'm going to go 6 plus ln 2 plus, let's see, I need 2 of these guys, because remember, you're going to add this and this, and then second time, so that was the first trapezoid. Second time, you're going to go this and this for this trapezoid, and then for this trapezoid, you'll go this and that. So we're going to double this guy here in the middle. All right, so we got ln 2 plus 6. I just reversed the order so I don't have to put extra parentheses around the 2. That kind of makes it a little bit nicer and easier for us. 24 plus ln 8, I need that one twice. I need the 42 plus ln 14 twice. And then the last one, 60 plus ln 20, we only need that one once. Okay, and maybe graphically it would be good for you to see that. So we're going to go with this guy once. Then we need this one again. that one and this one. And then we need that one and this one. So this one is once, this one's once, and we'll use this one twice, we'll use this one twice. So there's your 1, 2, 2, 1. All right, so putting that all into the calculator, you should get the following. In fact, let me just slide this over, and I'll keep it on that same line. It's about 633 point, and I think it was 3776. There we go. And it's an approximation, right? We round it off, so let's use the approximately sign. All right. Now, in the calculator, let's take this a step further. And I'll actually show you. We're going to do a 1/2 times the 6, but then we'll use some parentheses here. And remember, this came from just plugging in a 2 into the function. So I'm going to name a function y1, and then we're supposed to plug in 2 to that. Plus we need 2 of those y1s of 8s. Plus, again, 2 of these guys, that would be y1 of 14. And then plus 1 of these, y1 of 20s. All right. Now on an AP exam, you would never write out stuff that has calculator speak in it. You never write y1 on an AP exam. You would just write out what we had on the previous line, and that would be good enough. Not good enough, that would be perfect. All right, let me switch over to the calculator. Get your calculator out. Feel free to pause the video if you need to get caught up. And you'll notice down here, I'll just start typing. I'm going to go to the y equals screen, and you're going to see down here, I don't know if you can see the cursor, but down here you're going to see a y equals key press history. It's going to basically show you what I put in. I've already typed the equation in. You can see it there in the y1 slot. So what I want to do is, well, have you go ahead and do that. Pause the video if you need to. But I'm going to use this function and go back to the main screen, and you're going to love how simple this is. So we need that 1/2. So I'm going to go 1/2, right, times the 6. Now technically you don't need the parentheses around the 1/2, but I think most students like it better. You could also just put 0.5 or 0.5 times 6 times parentheses. Now we're going with that first term was vars right enter enter, and you're going to plug in a 2. Now you have to put parentheses around that 2, otherwise you get wrong values. Next up, we needed 2 of the next height, or I guess technically it's a base, because it was a B1 for one trapezoid and a B2 for the other. But we're still going to go vars right enter enter to pull that up, and we're going to plug in the 8. Repeat the process with another 2 out in front, vars right enter enter, and then you can put a 14. And then for the last one, do we double it or no? No, we do not. Vars right, enter, enter, and then put a 20. All right. Now you can either close or not close that final parentheses. Either way, we should be able to get it. Now, if you're really lucky, you could go math, enter, enter, but I know there's a natural log function in here. Math, turn it into a fraction, please. It's going to laugh at us and say, yeah, right. But had there not been, had we had like a simpler function in here, it's a pretty, you get a pretty good chance of coming up with the fractions sometimes. So, all right, so there you have it. Again, if you needed to, you could go back to through the video. Let me see if I can scroll through this right here. You can go back through the video, and you can see the buttons that I pressed here, line by line. It looks like just a maze of mess. But if you're following along and you're pretty comfortable with the calculator, it's probably not too crazy. Anyhow, let's go ahead and switch on over back to the notes, and I'm going to go ahead and move on to number 4. And these ones are going to go a little bit faster because they got a table set up for us already. So we'll just have to highlight a few ideas here. So we got g of x is given up here in the table. They want 5 trapezoids of equal length. So we'll do that same thing. That height, that common height, because it's trapezoids. If it were rectangles, you'd call it the common width or base. We're going to go high to low. So it's 8 minus the negative 2. and then we're going to divide that by the 5, the number of trapezoids they asked us for. And that is 10 over 5, which is 2. So knowing we're going to go from negative 2, if you add 2, you're going to go from here to here, then here to here. Add 2, add 2, add 2, add 2. All right, so that's your first, second, third, fourth, fifth trapezoid. And like we've done before, I'm going to underline this guy and this guy, and then this guy and this, nope, just kidding, not that guy, and this guy. So for the second trapezoid, so let's call this first, second, and so on, right? So for the first trapezoid, the bases are 2 and 3. For the second trapezoid, the bases are 3 and 1. For the third trapezoid, they are 1 and 2. And then for the fourth, they are 2 and nope. I keep doing that, sorry. Can I get it? It's cool. It'll be 2 and 4. And then for the fifth trapezoid, we're going to use 4 and 5. Let me just double check my work. Looks good. So this guy once, these guys twice, this guy once. In fact, let me highlight these guys right here. Let me redo that. These guys right here, you'll double those in our formula. And then these guys right here and here, the beginning and ending, we're not going to double those. All right, so let's get back to this color. So this can be approximated by 1/2 times our common height of 2. And then we're going to go 2 plus 2 of the 3's plus 2 of the 1's plus 2 of the 2's plus 2 of the 4's plus 1 little 5, and then we close it up. And from there, if we just work that out carefully, let's see, the 1/2 times the 2, those cancel out, so that's just a 1. And we're basically looking at 2 plus 6 plus 2 plus 4 plus 8 plus 5. Let's see, a 6 and a 4 is a 10, a 2 and an 8 is a 10. That's a 20, it looks like a 27 to me, 27 square units. All right, moving on, we've got our next, let's see, our next problem, number 5. We're going to go from -2 to 9, and that's going to change some things a little bit. And I'm also going to need to reuse this table up here. I didn't copy it down here onto number 5's space. So what I'm going to have to do, feel free to pause it and go back if you need to review number 4 a little bit. I'm going to go ahead and erase all of the mess we put on this table here, because it's a little different this time. So this time they said to go from -2 to 9, and they give us very specific intervals. So this is the first trapezoid, second, and this is the third. All right. So knowing those intervals makes it really quick and easy for us. Here's the first one. Here's the second one. Here's the third one, and don't expect them to be equal subintervals. So for this first one, that's a height of 2. This is a height of 4. To get from 4 to 9, that would be 5. All right. So now, let's see. We're not going to do the fancy doubling stuff in the middle, because that only happens when you got the equal subintervals and you can factor out that 2. That's not happening here. So what we're going to do for this one, we're going to say that this integral is approximated by 1/2 of, and we'll just take it one at a time. So we'll take the 2 that was up top here, and we're going to add the 2 bases, 2 and 3, plus, so that would be these 2 guys right here. Second one, let's see, that would be here and here. So it's 1/2 of this times the height is 4, sitting right here. And that's times the 3 plus the 2. And our third and final, we're going to use this 2 and this 4. And that'll be still 1/2, because that's the formula for trapezoids, times your new height of 5. It's sitting right there. And then you got a base 1 of 2 and a base 2 of 4, or vice versa. It doesn't matter which one is which. Now, what I said earlier about not being able to factor out the 1/2 and the 2, we can factor out the 1/2, right? I get that. But I want you to take a look at these bases here, excuse me, these heights. They are not the same. Whereas we were able to factor out the 2 because it was equal length subintervals, on the previous question, number 4. That's not happening down here. The 2 and the 4 and the 5, you can't factor those out. They're not a common factor. They're different. So we just take them as they come. Not a big deal. We just work through it, calculate. Let's see here. 1/2 of 2 is 1. 2 plus 3 is 5. Next we got a 2 is 4 over 2, and then that's times a 5. 3 plus 2. Next you got 5 over 2 times 2 plus 4, which is 6. So that turns into what? 10 plus 5 is 15, plus 6 over 2 is 3. 3 times 5 is 15. Final answer for that one, 30 square units. All right, moving on to number 6. All right, again, with